Okay, thank you. Well, the University of Alaska Anchorage was interested in digital signs and had been for a while. You see them everywhere nowadays. They're big and beautiful, and they're effective. And we were also interested in a new facility for medical programs. And so eventually we secured $50 million for the new building, which came to be known as the Health Sciences Building. And during one of these planning meetings, a friend of mine said, Pat Borjan has already designed a digital signage system, so maybe we should bring him in and hear what he has to say. He seems to think he can save us some money. It's kind of easy to get my foot in the door on this project, and it's because of successes that we've had with other systems that are designed on these web services. These R25 or 25 Live web services. So what we'll do is we'll look at the specs or the requirements, what we were looking at, what they wanted, and then we'll look at it kind of from three levels. From the end user perspective, because of course that's why we do all this, and then look at it from like a block diagram and architectural overview, and look at some of the automation pieces that keep it going 24/7, 365. This is another system that is 100% automated and works without any human interaction. Just by the nature of your people continuing to do their jobs, the schedulers and people use the web viewer and whatnot, submit their requests. Just by the nature of them continuing to do what they do, this system gets the schedule data out of the R25 database and makes it available on these digital signs. And then we can look at it at the source code if you're interested to see how it actually does what it's doing. And then have time for Q&A at the end. Okay, so just real quick, if you, just standard session etiquette rules, please be sure and turn up your cell phone ringers as loud as they can go. And if you do have a side conversation, please try and be as loud and annoying as possible, just so you can disturb as many people as possible. Just kidding. I just always thought it would be funny if somebody came up here and said that. I can see now that I was wrong. Let's see. Okay, so real quick, my name's Pat Borjan. I'm 42. I am a Sagittarius and a middle child. Okay. The University of Alaska Anchorage has between 15 and 16,000 students in the fall and spring semester, and we have about 7,800 students in the summer semester. And we have about 220 academic spaces or classrooms, and they're all in R25 now. It's all tracked in Resource25, and of those 220, approximately 70 are centrally scheduled rooms. And we have one person that's responsible for the academic scheduling of those 70 spaces, and there's another person that's responsible for the non-academic scheduling of those spaces. So, okay, so this is the specs. This is kind of what we were looking at. Some of these are self-imposed by myself, and some of them came forth from the working committee or the working group, the digital sign group. So, and this first one came from me. Just, if we can, let's make a system that works with all of the tablets. All right, let's not target a hardware or an operating system or a software platform. Let's see if we can come up with something that works with, all across the board. Because no matter how hot a tablet or a vendor is today, they could be gone tomorrow, right? And if the system supports, all across the board, it'd just be a lot more flexible, and it would bring down the total cost of ownership. So, and I'm talking 100% stock tablets. I don't want to have to, jailbreak or root or unlock anything. But I don't even want to have to add any free software, free or paid software. And I don't want to have to even, not even a web browser plugin. I don't want to have to install any extra software at all. You can go down to the store, buy your tablet, and it's compatible with this system. And I was successful. I was able to achieve that goal. And then closely related is the second spec is, we can use any hardware. So this digital sign system, it works with all the tablets out there, but it also works with smartphones and the netbooks, notebooks, laptop computers, the desktop computers, the servers and whatnot. It works all across the board, and so in a similar nature, it works with all the different versions of the operating systems, of the different operating systems out there. Android, Linux, Macintosh, the iOS, the Microsoft, whatnot, and all the various Unixes, the Solaris and AIX and all that good stuff. And it works with all the different web browsers out there, and with all the different versions of all the different web browsers out there. Opera, Chrome, Firefox, Dolphin, Skyfire, Internet Explorer, etc. And so, as probably some of you have realized, there's no binaries. This isn't a 32-bit or 64-bit digital sign system. You can think of it as a website, a web system with a controller in the middle. Basically, you can think of it as the display device, in this case the iPads, and then they talk to a web server to get their information. And that web server it has some automation, some pieces on it. And then it also is a client that talks to your web services server. And we'll get into the details of all this stuff. It's kind of the three-tier of this system. My dog, her breath literally smells like enchiladas and grape soda. And it's neat. If you know anything about me, my favorite food is always enchiladas. That's what I always get on my birthday. On December 6th, every year, that's what I have for dinner. It's my favorite meal. And I don't really drink sodas anymore, but when I was growing up, I would have enchiladas and grape soda. The third spec of the system is these digital signs, they really need to be able to go into an emergency mode in a moment's notice. Because, for example, if there's a mother moose with her babies outside the east entrance of the administration building, then that's the last place in the world that your students, staff, faculty, your guests, visitors, whatnot, should be going. So if you think about the strategic advantage of having these displays throughout your system, throughout your campus, or campus locations, it's pretty neat that you can, in a moment's notice, relay information to your folks. And even though, so many people carry their smartphones and texting and whatnot, on one hand, we encourage them to disable all of that when they walk into a classroom, typically, so that they're not interrupting, or so that the telephone calls aren't interrupting the lecture or the learning process. So, so these signs, they can display emergency information in a similar fashion to how they just go about regularly getting their schedule information, which is through these behind-the-scenes AJAX requests, right? The display comes up, displays its info, and then in the background it just sits there and makes these AJAX requests to see if there's updated info. And I think I have my signs in this health science building set for every 50 seconds to check for new schedule info. But the emergency checks, so the check for emergency information happens a lot more frequently. And it's just a background AJAX request, a JavaScript request. Okay, the fourth spec is, in the event of a network failure, these signs, since this is a website or a web system, they should just continue to display the last schedule information that they had. And when the network comes back available again, they should just silently resume. So a person walking by should never be able to tell if the Wi-Fi network is currently down. They should never see one of these web page not available error messages. And I was able to achieve that. Just because if the AJAX query fails, it means network's down, it can't get to the server. It just says okay, and it just waits for the next 50-second cycle, and then it just tries again. But the display doesn't change. The fifth proposed spec requirement, this one wasn't really a requirement. I suggested this, but they actually weren't very interested in it. Can we dim these displays when they're not needed? So, at 2 a.m., if the building's locked up or folks aren't there, can these signs can they shut themselves down or go into a low power standby mode? And it turns out that these medical programs, these folks are in there, or have the ability to be in there, a lot more than the traditional classroom setting, I guess you could say. So they weren't really interested in doing that. And since this really are just a website access from one level, you can think of it as just website access, I couldn't do that anyways. But there are a couple options available. Some tablets you can set them to, go to sleep and then come back to life at a certain time of day, just like with desktop computers and a lot of laptops nowadays. But as an alternative, what you could do is just send them to a plain black screen, a plain black web page basically, that has no information on it and dims the display as much as possible. So I was talking about safety and emergency mode. This is a full-grown moose on the left that's standing next to a Honda CRX, which I shot these pictures from the back porch of a apartment that I used to live in up here in Anchorage. And then the picture on the right is that same moose. It had stepped forward a few feet and was standing next to our car, which is a Honda CRV. And the top of that green car on the right is about 6 feet tall. So you can see these things are, they get pretty big and they're very strong. Okay, and then the next spec or requirement is, can we have a stock ticker type ability so that we can scroll or display whatever additional information we want. And the premise here is that by default, what you see on the signs is what's scheduled in that location for that day. So if it's in Banner, which is our student information system, and it's so for example the health science building is HSB, and for example we'll use room 101 as an example. So the iPad or the digital sign for HSB 101 is going to be sitting mounted to the wall just outside of the door to room 101. So but if you know for example, if there's a lecturer person coming to town to talk about, I don't know, neurology or some medical aspect that's relevant to the people who will be going into that room, then it can be advantageous to have that info on that sign, since those people are going to be walking right by it and they'll look at the sign. So we send email, we send alerts, we have newsletters and all that stuff. But if a person is going into HSB room 101 and they would like to know about this person coming to town because they're interested in that information, then why not? Let's put it on that sign right there. And if the amount of information, the number of characters or words, is too large to fit on the iPad, then it will just automatically scroll horizontally. So and I was able to achieve that again in a similar fashion with regular schedule information. And what I did is I just created a resource in R25. So it would be called something like digitalsign.hsb.101.stockticker. And then set up security. Whoever has permissions can go in there, put text into that resource in the R25 system, and then that will show up on the display. Okay, so then the next spec is extensibility or scalability. This system, it needs to be flexible so that we can add and remove signs very easy, and it has to scale in case this pilot project took off. And basically it's extremely simple. What you need to do is you need to know the room name, like HSB 101, and then you also need to know the unique identifier for that space in Resource25, in R25. And you can find that very simple, especially using web services. Okay, some groups, the next spec, some groups don't use R25/25 Live, but they've seen these signs and they want signs. They want to be part of the system. Can we have signs that display their schedule information too? And the answer is yes. I actually had already designed other systems that go out and grab other people's schedule information and stuff it into Resource25 using these web services. And so the answer is absolutely yes. We can show anybody's information on these signs, whether or not they use R25. Okay, so what we have is the system that is a unidirectional system for students, and that is it displays the schedule information on these signs, and that's pretty much it. And the stock ticker can display other information as well, relevant information, and then it can also display this emergency information. But the system is also color coded so that if I need to make a phone call, I need a quick meeting room, I'm just going to run in there for 5 minutes, I just got to talk to somebody about something real quick or whatnot, whatever the purpose is. If I stand up and I look down the hall and I can see that room from where I'm at, I can tell if that room is being used or not. So I can already tell if there's somebody in there without having to walk down the hall. And then again for the next room, and again for the next room if the room is taken. Because if the room is being used, then from far away without reading any text you can tell, because what you'll see is red. I have some supporting graphics. For health science I used a test tube and on the left side of the screen and an apple on the right side. And whenever the space is being used, the liquid in the test tube is red and the apple is red. And then whenever it's not being used, the supporting graphics are green. So from far away, just by glancing at it, I can tell if the space is being used, if that room is available for me to go run in and take for a few minutes. And then I said it's unidirectional for students. It is bidirectional for people who have the authorization, the passcodes. And what I did was I created this little system that there's an invisible keypad on the displays. And so if you know where to tap, and you know what order to tap, and you know the rate, like how fast and slow to tap, then you can walk up to one of these signs and tap in a certain sequence at a certain speed. And if you do that correctly, then a password dialog box will pop up. And then when that text input box pops up, the soft keyboard pops up on the screen too. So you can enter the password. If you know the password, then you get to another screen that allows you to reserve that room while standing right there at the display. And again, typically this would go back to the scenario where you just need the room for a few minutes. You need it right now, right? So you don't want to go through the normal scheduling procedures to submit a request, or if you have permissions to fire up R25 and schedule the space. So you can just click one of the drop downs of predetermined time, like 5 minutes, 10 minutes, 15 minutes, and then a quick description, and you click go, and then that's it, and then the sign will update itself. So it's a one-way system for students and for most people, but for the people who have the passcodes and know where to tap on the screen, it's a two-way system. So here is an example of one of the signs. And again, you can tell, we can't read any of the text because it's too small, but you can tell right now that because of the red supporting graphics, the space is being used. Okay, so this is an example of one of the signs. This is an example of one of the layouts for one of the signs. So, and again, this is an HTML web page, and what I did is add some Apple specific meta tags that takes away the URL bar. And in fact, for those of you that have iPads, you probably recognize the little icons here. The clock is in the middle, and then the battery level is off to the right. But this is just a web page, and the HTML, it has these meta tags, a couple things, and then it says image. So there's an HTML image tag, which is this background thing, and then everything else is just divs, HTML div tags. And what I did is all of this information is the schedule information. And by the way, right now it's 12:16, so between 12 and 1 p.m. So this is the this is what's occurring right now in this classroom. And this tube, this liquid is red, and the apple is a red apple because the room is being used. So we have this div for the schedule information. We have one for the tube over here, one for the apple with the word in session on it. We have one div for this graphic. This hovers above the other graphic to say the building and room. And then this information is a little bit different now. I think it includes contact information, that's right, for whoever is responsible for this room. So it gives their telephone number and I think their name or maybe their email address. It's been a while since I looked at it. And then down here is a div that we include the time and date. And again, just as another reference. The apple happens to display the time up here, but again, wanted to make the system supported by as many devices as possible, and some don't display the time at the top. So I didn't want to rely on that. So that's kind of it, and you can, and then the stock ticker information is not enabled for this display or for this layout, but basically it would just scroll across here, and in other displays it scrolls all the way across the bottom. And this text is it's this font size because of how many characters there are from here to here, and because of how many entries there are. So this text, the font size adjusts itself to maximize the horizontal and vertical use of this space. So if there's one or two events occurring in this room on this day, then this font will be much, much bigger to try and fill up as much of this space as it can. Okay, and then a couple other layouts that were drafts. This one is real similar. This one includes a photograph of what's inside the room. The info that I'm including is the same. The layout and the graphic elements are what's different. And just as a note, this is an HTML web page, but the schedule data, for those of you that are familiar, this system is based on PHP, but it could just as well be Cold Fusion or the Microsoft, the .NET stuff. It could be Python or Perl or whatever else you want to do. The time and date happens to be a JavaScript routine in the HTML. And really this could be I could have done this with what they call server-side includes, the SSI or SHTML. Because all it does is when the display, the iPad in this case, requests the web page for itself, so that would be like, well, in this case it would be hsb207.html. When it requests that web page, the web server says, well, hang on, this is a PHP page, so I need to pass it off to the PHP preprocessor. And then PHP says, oh, okay, I need to go and include the data file for this web page, which in this case the data file is just an HTML formatted schedule information file. So that's kind of it. I mean, it's pretty basic. The device boots up, it requests itself, HTTP:// your url.edu/digitalsign/hsb207.html. The web server goes and gets the data file for that room, plops it down in here, and then sends the HTML back to the device. And you can lay the information out however you like, right? I got to walk around the health science building, do some photographs, and get some information about what they were looking at for the system, and I saw a doll that cost, I think they said, about $80,000. And this is it. You know, its heart, its chest moves up and down as it breathes. These medical students, they have to stick needles into, draw blood and learn about taking pulse and all this stuff. And I showed this to my wife when I was practicing this presentation. I said, "Look at this doll. This thing's kind of creepy, don't you think?" And she looked over at it and she said, "Ugh, you're going to show that in the digital sign presentation? Why would you do that? That thing's kind of creepy." And I said, "Well, no, you're right. Do you want to see it closer?" And she's like, "Ugh." And I said, "Well, what do you mean? Do you want to see it in 3D? So, just kidding. Look, one thing I wanted to emphasize or go back to is the notion of the data. You have your schedule information, and this supplementary information like the stock ticker and the time and date is on there in the room there. But focusing on the data, your scheduled data. So what's going on in that room for that day, and that is completely separate from how the data is presented. Okay, there's a design pattern or theory called MVC, Model View Controller, and they seek to completely separate the information from how the information is presented. And it's similar with this system, with this digital sign system. You can hand the HTML and the CSS to your graphics folks, your layout people, your artists, the designers, and they can decide, basically that's their expertise or their domain. That's what they do best. You can give it to them and let them design, and they can do focus groups or whatever, design where the information appears, how it appears, what supporting elements you have, but that is completely separate from the facts, if you will, from the actual scheduled data. So I just wanted to mention that this system supports the notion that there's the data, and then there's this other element, which is how the data is presented. Okay, so I'll just step through this real quick as we get into the architectural overview. This is Resource25 at UAA. Okay, and at the heart of it all is the schedule database. And this is the same database whether you're using R25 or if you're using 25 Live, or a combination of both. But this is our schedule database. And up here we have the R25 app server. And for us, we're a Citrix shop for R25 anyways. So R25 is just installed in one place, and that's really neat. It's real handy. And it means R25 runs, on all these different devices because Citrix runs on all these different devices. So we have R25 up here, and then we have the web viewer, which sits right here, and the web server sitting in front of it. And this is the public internet. And then in front of the database, we also have this web services server. And then this other little system that I designed that, again, it uses web services, get the scheduled data out, and then I have a little Apache web server and a MySQL database server, and I made some little search engines, some calendars, a couple things like that. And that also is available to the general public. Okay, and then going down we have the bridge, the R25 to SIS interface, which this travels about 356 miles north up to Banner, up to our Banner cluster up in Fairbanks, Alaska. I guess let me go back here, I skipped this. The digital sign cluster, the digital signs, they just go and ask for http:// blah blah blah.edu/ hsb101.html. And so they literally are just requesting that from a web server. And then in the background, they make these little AJAX requests every 50 seconds to see if there's new scheduled data. Each one does that it should be displaying. And then this system, in turn, it periodically goes out and polls the web services server for each room to see if it needs to get new schedule data for the displays. And we'll get into that in just a minute. And then I have this other web services server that's used for pushing data into the database. So these people, none of these other groups on campus use R25, but I was able to extract their data just into a simple CSV file. Get a new event template, a new event web services template, populate the variables in it with data from these other folks one at a time, and then do a bunch of pushes to push all their schedule information into the R25 database. And then it's available. It's available to R25 users, it's available to the web viewer folks, to this custom stuff, and it's available on the signs. Okay, so we'll get in. This is the beginning of that 3-tier system. So you have the signs, and they talk to the web server, and then it goes out and gets the information, the schedule information, and it sends back that HTML web page. And then from then on, every 50 seconds, they just make this little AJAX request. And what they're asking for is the date stamp for themselves. So for the example of HSB 101, that sign would say, what is the date stamp for the data file, which is the schedule information? What is the date stamp for the schedule file for HSB 101? And it gets that value back, and then it compares it with what it had previously. And if it's the same, that means that the schedule information for HSB 101 has not been modified. And so that's fine, and it goes back to sleep and it waits another 50 seconds and it requests it again. But if something has changed, then it just goes out and re-requests its page, hsb101.html. And now, there are design considerations and trade-offs that I made. There always is. But it was very simple to arrive at this conclusion, because what it actually downloads is just that schedule information. Even though it says, oh, I need to reload my sign, I'm going to go ask for the whole web page again. Because of caching and the Safari browser that's built into the iPad, it asks for that page, and the web server says, okay, well, that apple hasn't changed, that test tube hasn't changed, the graphic of your room, the building and room number hasn't changed, the background of the whole display hasn't changed. So really all it sends back is the changed schedule information, which is very small. And every 50 seconds when it requests that timestamp, that's an 11-byte file, so that is extremely light on your network. Okay, and then the other half then, separate from that, is that this thing comes to life every once in a while, and it pulls the web services server for each of the rooms. And so for the example of HSB 101, it says, hey, what is the schedule information for HSB 101 for this day? And then it compares what it gets back to what it has in that data file sitting out in the file system. And if it does a diff, a Unix command called diff, and it literally is just comparing to see if there's any differences in the two files, the one it just got with the one that it has stored. And if there is no change, then it just goes on to the next room, HSB 102, for example. But if there is a change, then it saves that new data file out to the file system so that these signs can get it next time, and it updates that timestamp file so that when this thing makes that web services request, it can see, oh, something has changed. I need to re-request my page. So this, I basically stepped through this. I guess I did this one. Okay, so actually, let me back up a second. So when the controller is talking, when it's being a web services client, it's doing that using a Unix command line command called curl. And it gets the current day schedule information. So, for example, whatever the URL you have is, and then it uses the room reservations.xml. It uses that part of the API, and it provides the space ID for HSB 101, and then it says, oh, and transform it, change it, convert it into HTML, because all I'm going to do is feed it back to the sign, so it needs to already be HTML. It's just part of the web page. And then see if there's any new schedule data, so diff-q, the last data file with this data file, the one you just got, and then if yes, copy it and increment the timestamp. Okay, and so for the curious, this is some web services details about how we get that schedule information and make it available. This is an example URL where we're calling roomreservations.xml, and then we provide the space ID, so it would be like 798 or whatever, whatever the ID is in your database for your particular room. And then if I just did that, if I just called back room reservations, all of this http:// blah blah room reservations.xml, I would get all of the reservations, I think for the current day that I have permissions to see, because before you do any of this, you have to authenticate. You have to give an R25 username and password, and I would get it back in XML formatted data. But if I throw on this parameter, roomreservations.xml, but space ID equals this, then I would just see all of the reservations occurring on this day, on the current day, that are occurring in this space, if I have permissions to see them. But what we need to do is do a little transformation that converts that XML data for this space for the current day, converts it into HTML. So let's see what so this would be the XML that you get back, and even though you can't read it, you can see here, you can see these red things are like the space reservation. If we zoom in on that, reservation start date, so this is actually a date and time, and then reservation end date. And then here's the space ID, 797 in our database equals HSB room 208. Okay, and then you have the event name, MedT 202 section 1. And then the title, that's clinical chem. So if we go and look at, after it goes through the XSLT, or the XSL transformation, what we get is, it looks more like this. The data that we picked out of that XML, and then the font and the color and the size that we specified. And that's not specified in the XSLT, and that's kind of important to understand. In the XSLT, we get the data that we want, and we assign it a class, a CSS class, so that's part of separating the data from the presentation layer. And then once it has a class associated with it, or that defines it, your graphics artist, your layout people, whatnot, they can define the characteristics of that class. So they can say, use red font, use a red color, use this type of font, use this size, and other characteristics or attributes like that. And then here is, we go back to the display, and then this is where that chunk of information would go in this HTML div. So real quick, I guess here is the actual text of the transformation that I'm using. So I'll go down here. Okay, so template match rows are roots. We're starting from the beginning of the XML doc. We create a variable called row county, and that's just the count of how many rows. And again, we do that because if there's only 2 reservations in the room today, then we can assign a different style so that the CSS can say make the font bigger. Okay, so div class. Okay, so here we go. So if the row count is less than 1, because we're doing an XSL test here, when the row count is less than 1, then you do a div class equals div no events, and then in CSS we can specify the attributes about that class. And I just put the text as being nothing scheduled today. And then if there's 1 or 2 events, so if the row count is greater than 0 and the row count is less than 3, then the class equals div count1. And again, your folks can go and set the attributes of that style, of that class. And we just show some of the information. The R25 event, the start date, the end date, whatnot. The title, and then we test lowercase. Okay, so if the event name, so we lowercase it first, and then if the event name does not equal the lowercase version of the event title, then go ahead and show it. Show that event name, because what I saw is that non-academic events or non-academic occurrences will sometimes have the same event name and title, and so we don't want to show it twice, like outdoor picnic 1 to 2 p.m. or whatever. But the academic stuff that comes from Banner, it would be like, accounting 101 section 1, and then the next line would say introduction to accounting or whatever. So those are 2 different values. Okay, and then right here we do a test. If the time is greater than, if right now is greater than the start time, and if right now is less than the end time of whatever event you're parsing, then throw in this little span, in session.